Corn is one of the most important crops on Earth, feeding people, livestock, and industries across the globe. Yet few ever see the immense, carefully engineered system of machines and technology required to plant millions of acres, irrigate them with precision, and harvest the crop at massive scale. Behind every cornfield is a world of satellite-guided tractors, computer-controlled planters, irrigation pivots the length of football fields, towering harvesting combines, grain carts, dryers, conveyors, and storage systems that together form one of the most efficient agricultural operations on the planet. And today, on the How Factory, we're going deep into this world to reveal how corn is planted, irrigated, grown, and harvested with giant industrial machines that transform farming into a coordinated mechanical ecosystem. What begins as a tiny seed placed into the soil with millimeter accuracy ends months later in a harvest that moves thousands of tons of corn from field to storage in hours. The process begins long before a single seed touches the soil. Modern corn farming starts with soil preparation, mapping, and nutrient planning. Farmers collect data using GPS surveys, soil probes, drones, and yield maps from previous seasons. These tools reveal every detail of the land: organic matter levels, pH, compaction, moisture, and nutrient distribution. Software converts this data into digital field maps that guide nearly every machine used during planting and irrigation. Once planting is complete, the farmer prepares the soil using massive tractors, pulling tillage implements such as chisel plows, vertical till machines, or field cultivators. These machines break up compacted ground, incorporate crop residue, smooth the seedbed, and create an environment where seeds can germinate evenly. Some farms practice no-till farming, allowing specialized planters to cut through last year's residue without major soil disturbance, reducing erosion and improving soil health. When the field is ready, planting begins. And modern planters are some of the most advanced machines in agriculture. A planting tractor, often 300 to 500 horsepower, pulls a planter that may stretch 12, 24, or even 48 rows wide. GPS and RTK satellite correction systems guide the tractor with sub-inch accuracy. This precision ensures perfectly straight rows and avoids overlaps or gaps. As the planter moves forward, seed hoppers feed individual row units equipped with vacuum or electric meters. These meters singulate seeds, picking them one by one and dropping them at exact intervals, often 6 to 8 inches apart. Downforce sensors measure soil hardness and adjust pressure so seeds are buried at precise depths, typically around 2 inches. Furrow-closer wheels press the soil back over the seed, ensuring ideal soil contact. Liquid or dry fertilizer systems may apply nutrients directly into the seed zone. Throughout planting, onboard computers monitor seed population, spacing accuracy, speed, and ground conditions. The entire system ensures that every seed enters the soil in the perfect environment for germination. Once seeds sprout and begin growing, irrigation becomes the next major challenge, especially in regions where rainfall is inconsistent. The most iconic irrigation machines are center pivot systems, enormous steel structures hundreds of meters long that rotate around a central water tower. Each pivot consists of multiple wheel towers connected by truss-supported pipe sections. Motors drive the wheels slowly around the field, sweeping the pivot in circular arcs. Water flows from wells, reservoirs, or canals through the pivot, spraying onto the crop through pressure-regulated nozzles spaced along the pipe. Modern pivots use variable rate irrigation technology. GPS maps and soil sensors tell the pivot which sections need more or less water. Software controls valves that adjust flow rates in real time. Some pivots carry remote sensors measuring temperature, humidity, and soil moisture. Others use drop nozzles to deliver water closer to the ground, reducing evaporation. Linear irrigation systems, long machines that move in straight lines, water rectangular fields. Drip systems deliver water directly underground to plant roots. All these systems help ensure the corn receives the exact amount of moisture needed for healthy growth while minimizing waste. Throughout the growing season, massive sprayers move across fields applying fertilizer, herbicides, or foliar nutrients as needed. High-clearance sprayers with booms up to 120 feet wide ride on tall wheels that pass over rows without touching the plants. GPS mapping and section control technology prevent double spraying or missing areas. Many sprayers use nozzle control systems that adjust droplet size to improve coverage and reduce drift. Drones and satellite imagery monitor crop health, detect stress areas, and guide mid-season decisions. Fertilizer spreaders and side dress applicators deliver nitrogen at precise rates based on plant needs, ensuring healthy ear development. By midsummer, corn plants may stand more than 8 feet tall, forming dense canopies that rely on careful water and nutrient management. As corn matures, ears fill with kernels and moisture levels gradually decline. The timing of harvest is critical. Too early and kernels contain too much moisture for efficient storage. Too late and weather can damage the crop. When the moisture level drops to around 18 to 25% in the field, harvest begins. And this is where one of the most impressive machines in modern farming takes center stage: the combine harvester. A combine is an enormous self-propelled machine that performs 3 tasks simultaneously: cutting the crop, separating kernels from cobs, and cleaning the grain. For corn, the combine is outfitted with a specialized corn head, a wide attachment with rows of gathering snouts that guide stalks into the machine. Rotating stalk rollers pull the plant downward, while snapping plates strip the ears from the stalks. The ears then travel into the feeder house and into the threshing system. Inside the combine, a high-speed rotor or cylinder grinds the ears against concaves, freeing kernels from cobs. The mixture falls onto sieves where forced air blows away husks, leaves, and debris. Clean yellow kernels drop into the grain tank while cobs and plant material are expelled from the back of the machine, spreading chopped residue across the field to decompose and enrich the soil. Sensors inside the combine measure grain loss, kernel quality, and flow rate, automatically adjusting rotor speed, fan settings, and sieve openings. This ensures maximum yield with minimal waste. As the grain tank fills, often holding 300 to 400 bushels, the combine unloads on the move. A long auger swings out and pours kernels into a grain cart, pulled by a tractor driving beside the combine. This synchronized motion keeps the combine harvesting non-stop, improving efficiency. The grain cart then delivers corn to waiting semi-trucks at the field edge. Each truck hauls the crop to grain bins, elevators, or on-farm storage facilities. Once delivered, the corn must be dried to safe storage moisture, usually around 14%. Grain dryers use heated air to evaporate moisture from kernels as they move through drying columns. Large operations may use continuous flow dryers capable of processing thousands of bushels per hour. Temperature, airflow, and humidity inside the dryer are tightly controlled to avoid cracking kernels or reducing quality. After drying, corn is moved via bucket elevators, chain conveyors, or pneumatic tubes into huge steel storage bins. These bins may hold hundreds of thousands of bushels. Inside the bins, aeration fans push air up through the grain to prevent heat pockets and condensation. Sensors track moisture, temperature, and insect activity, so the corn remains stable for months until it is sold or processed. Behind the scenes, technology ties the entire corn production system together. GPS systems guide tractors with near-perfect accuracy. Telematics networks transmit performance data from machines to farm offices. Automated monitors track yield, moisture, and productivity in real time. Agronomists analyze tissue samples, drone imagery, and soil metrics to fine-tune management decisions. Weather stations on farms relay data that influences irrigation schedules and spraying windows. Even the massive combines are connected, capable of sharing yield maps wirelessly with the next season's planning software. What makes modern corn production extraordinary is the combination of biological growth and heavy industrial machinery. Seeds are placed with surgical precision. Irrigation pivots march across fields like moving steel giants, distributing water with mathematical accuracy. Sprayers glide above rows applying nutrients in targeted doses. Combines tear through fields, separating tons of grain in minutes. Grain bins, conveyors, and dryers ensure the crop reaches storage safely. Every stage blends natural growth cycles with mechanical efficiency. And that is exactly how corn is planted with GPS-guided planters, irrigated by massive pivots, fertilized by high-tech sprayers, harvested by towering combines, dried, stored, and shipped into the global food system. An incredible fusion of agricultural science, advanced machinery, and precision engineering powering one of the world's most essential crops. Thanks for watching the How Factory, where we reveal how the world really works. Don't forget to like, subscribe, and join us again for more deep dives into the machines and systems behind everyday products.